Hi, I'm Michael Mandanas. I'm 14 and a rising sophomore, and I'd like to talk to you today about translational motion. Now, in order to think about translational motion, we're going to need to know a few variables and a few equations. Now, the ones I will be using are delta t. Delta just means change in, so change in time. We will need to know change in distance. We'll need to know acceleration, initial velocity, and final velocity. Now, there are three main equations we're going to use. The first one is that the change in distance equals the initial velocity times the change in time, plus 1/2 the acceleration times the change in time squared. Second equation is the final velocity equals the initial velocity plus acceleration times time. And the final equation is the final velocity squared equals the initial velocity squared plus 2 times acceleration times the change in distance. Alright, let's do some sample problems. Now, let's start with this one. A car starts from 0 meters per second and can accelerate at a maximum rate of 12 meters per second squared. Find the car's speed after 5 seconds if it accelerates at its maximum rate, starting from rest. Alright. When working with problems, it's always a good idea to start with what you know. So, we know that the initial velocity is 0 meters per second. We know that the acceleration is 12 meters per second squared. We know that the change in time is 5 seconds, and we need to know the change in velocity. Now, let's start with an equation which combines all of these things. The equation we will be using is the final velocity equals the initial velocity plus acceleration times the change in time. Alright, let's plug in some numbers. So, the final velocity equals 0 meters per second plus 12 meters per second squared times 5 seconds. Now, simplifying, we get 0 meters per second plus 60 meters per second. And finally, the final velocity is 60 meters per second. Let's move on. Another sample problem. So, a car starts from 0 meters per second and it can accelerate at a maximum rate of 12 meters per second. So, it's the same car as in the last problem. Find the distance that the car travels after 8 seconds if it accelerates at its maximum rate starting from rest. Alright, let's start from what we know again. We know the initial velocity is 0 meters per second. We know that the change in time is 8 seconds. And we know that the acceleration is 12 meters per second squared. We are tasked with finding the change in distance. Alright, let's have our equation now. Delta x equals vi delta t plus 1/2 a delta t squared. Okay, plugging in some numbers, we get delta x equals 0 meters per second times 8 seconds, plus 1/2 times 12 meters per second squared times 8 seconds squared. Simplifying, we get 0 meters plus 384 meters, so the distance traveled is 384 meters. Now, I hope this video was helpful. This is Michael Mandanas signing off.